Good morning, students. Today we are going to see some computer architecture topic, both multiplications. First of all, we want to know what are the numbers are there, what is the process multiplication we know. Okay, first of all, we'll see about the some simple examples. Suppose we take them as small numbers. Numbers is become as it is a minus 4 multiply with plus. The plus 5, you already know the value is minus 20. Suppose when I go from as a minus 4 into plus 5, minus 4 multiply with the plus 5. Okay. Here we will not perform as the addition, we already know. Add, we know the binary addition. Suppose I it is the 0, 0, 1 and adding with the 1, it becomes as a 0, 1, 0 sort. But I do from the same process from that is a 1 and 1 want to be added. Suppose you want to perform as it is a 2 minus 1 want to perform here. 2 minus 1 want to perform. That is also answer is 1. But we will not do from as a subtraction. We will do from subtraction, but we will not do it. Okay, instead of doing by the minus, we will do from as the addition process. Addition process. For that, we have the number as the 0, 0, 1, 0. The minus 1 is there now, minus 1 converted it is a 2's complement. For 1 having the what is number 0, 0, 1. 2's complement, 1's complement done here 1, 1, 1, 0. Then adding with 1 we got the value equal to 1's are there. So we will not do from a subtraction, we want to do the operation having it is the addition operation be carried out. We are do from as addition operation, so both answer be same. Suppose having it is a 0 plus 1 is having it is that is a 1. 1 plus 1 equal to we having it is a 0, carry is 1. So 1 plus 1 equal to 0, carry is 1. 1 plus 1 equal to 0. So we got from as the answer from as a 1. That is only that we are not doing subtraction. Subtraction, whenever negative numbers are there, convert to 2's complement, then perform the addition operation. Addition operation we want to take it out. That is having it is our agenda for that first of all. Okay. Now we have that is a good multiplication. We have that is a and we have the multiplicand is available and multiplier is available. Multiplier will take some number example that is a some number we take. Suppose consider that is a, already examples are available. Suppose if you want to change the example also you can able to change. Suppose having that is a 3. 3 you want to be there now 3. The having that is the 3. We have in 3 into 5. It is having is very less numbers are there. We'll take them as a 5 minus 5 into minus 1. Okay, the minus 5 into minus 5 you want to take. So first of all take a 5 number. Okay, then take them as the minus 5 number will be there. Okay, take them as it is a 4 is there. Okay, 5 into 4 it is also same. So having this a 5 is there, having the multiplier, having this a multiplier, having this a 4 is there. So what is the first process there? We want to calculating by here. We want to apply from as a minus 5. We want to calculating by the minus 5 and have to be as a 5 want to multiply. The answer become that is here. The answer become that it is become as a 25. Okay, minus 25. Okay, you want to know now what is minus 25 binary value. For that 25 binary value become that is 16 plus 4 plus 16 plus 16 plus 8. 16 plus 8 become that is 24. 24 plus 1 become as a 25. So you can able to check whether it's 25 coming or not. 25 is coming. So what is our agenda is the 16th bit and 8th bit having this first bit. So we having the number system. We have this first go from as the 8 4 2 1 2 1 method. Here we have 16s are available. 16 right hand side 2 want to multiply 64, then 128, then 256. Okay, these are the our number systems are available. Okay, 64, 128, 256. Yeah, the number is okay, number is available. The 9 bits are they come considered by only from the 8-bit number. We don't know this last. So what is having is the 25 as a binary value is that we having is 0. Initially have to be what are bits are they 16 plus 1 plus then 1. Rest of thing we having the adding with 0. So adding with 0. Okay, that become that is the value become as 25 are there. But we want to know the minus 25 now. Minus 25 mean you want to take as a ones complement want to perform first. The first perform by that is a ones complement. Okay. Then perform by that is a two's complement. Two's complement want to perform. Okay. Two's complement want to perform. Okay. Ones complement we do from as that is a converted to the ones into zero. Zeros and all one. So here a one, here one, here one, 0, 0, 0, then 1, 1, 0. This our numbers are there. Then after adding with the here is the one want to add from as the least significant bit. After add here, we got the value is that here is the 1, 1, 1, 0. Here you want to add from as a 1, 1 added, then 1, here 1. So here also 0. This become that is a minus 25 is a value. Minus 25 is a value. So we'll check it whether it is coming the same answer by applying from that is the number. Suppose this number is a minus 25. This value becomes as a minus 25. So when I have converting this Excel decimal to binary, you want to give the reference about this cell. Okay, with reference to be given. So the number converted to this as a negative. Now this number be multiplied into this a decimal to binary. The decimal to binary gives number and percent. Now the number I will modify into the 8 bits. 8 bit number is the value. Suppose you want converting by the answer we already know. Converting the number into the decimal to binary this number, we got the value. You see here what is number you having the number 8 bit numbers are available here 4 bit and here 4 bit. That 4 bit means first 4 bit, here also 4 bits are there, extra 2 bits are there. We when adding from as in front of the negative number is a negative one won't be added, nothing will be changed. This from as a normal procedure. But how it's happening from as a design binary multiplication mean what the number is there number. The number having is the 5 is there. 5 mean what is the 5 binary value. We know that the 5 having the binary value. Normal having the binary multiplication. We having that is the 5. First consider by the plus 5 want to write. The plus 5 equal to 0, 1 or 2. Okay. Next, the number you confirm as a 1's complement. Okay, take them as a 1, 0, 1, 0. Then adding with the 2's complement. Okay, 2's complement adding with the 1. So having it is a 1, 0, 1, 1. This become as a minus 5. Okay, what is plus 5 value? Plus 5 value already know 0, 1 or 2. This from our value. So if this is our process, and I do from as a normal multiplication process. So you want to write this value. So write this value. You want to write 1, 0, 1, 1, then multiplication with having the 0, 0, 1, 0, then 1. Okay, this is our number. This is our number. We'll just make it as some different colors to bigger font. These are our numbers. These are our numbers. Okay, 1011 and 010. First of all, what you do here, you want to multiply the number. Okay, multiply number. First step. Okay, we'll do this is not having the color. Otherwise, we'll apply from separate color for here. This is the one color. This is from another color. Okay, this is will keep it as opposite color like yeah. Okay, this is our number. So when I want to do the process now, one multiply by anything, we get the value is the same value. So what is the values are there? We got the value equal to like okay. Next having the zeros are there. Zeros mean you want to add that 0, 0, 0. Okay, one bit we leave it. Next you want to multiply as a 101. So you want to write the 101. Next bit having the zeros will be there. 0. We start from as the here 0, then 0, 0, 0. 4 bits are there. Now what I do here, instead of that, I have to move from a somewhat left hand side. Okay, left hand side I have to move here. Now this number I move from another little bit towards because why now we having it is a 4-bit number and a 4-bit number multiply. We had to produce from as 8-bit number only produce, but totally we have it is a 4 plus 3 7-bit number only available. So we adding by the one extra bit want to be added. The extra bit what is going to here now? We want to adding by this number want to make from as the adding will be done. But this process, how we want to add the number now? Behind what the last bit number is there. Here first of all add from as here on 0 because last bit is signed bit. Okay, we want to adding by the same bit we can extend by the here. Okay, here what the last bit is a 1. So yeah, when that is written by the 1 comma 1. So you want to be as a apply by the same color here. Okay, we apply by the same color. That means that we have to copy paste these two values. Now what is last bit value? 0, 0, 0, 0. Okay, here what is last bit value is the 1. Last bit value is the 1. is written by the same value. Okay, written by the same value here, here, here. Now you see that just to make the aligned, okay, align we make the center. Okay, these are all the bits entry. Now what you do here, perform from as the addition process will be taken place, addition. Okay, when I perform from as the addition process, okay, here, the first one is there, one, here one, one. Here one means 0. Here as a carry is 1. So it is having this is 0. Here what is the triple 1 is having carry. Okay, 1 we having carry. So we having that is the extra bit. Suppose we having this 1 is having carry. Here also 1 is carry. Okay, here also this nothing happen. This having is the 0 is there, then carry is 1. So here what is the value be there? Here having is the triple 1. 1 mean here also carry is 1. Then here also having is carry is 1. So our answer will be as a received by this is our answer. So what is the answer for here? Okay, you will see here what is the answer we found from as that is the normal procedure. Okay, we having the triple one, triple one zero and zero triple one. So having the triple one zero, zero triple one. So this is from as that is a manual multiplication. We got the answer. This answer become as that is a minus 25. So this is only want to prove it when I do from as a booth multiplication. We having that is the flow chart is available. What is the flow chart represented? We have to give them as the accumulators be available and accumulator be slicing 0, qn minus 1 bit having 0, sequence count take number of bits. We want to check from as the qn comma and qn minus 1 bit I want to check. Should be having that is a 0 0 or 1 1s are there, no operation perform as arithmetic separate operation. After performing arithmetic separate operation, we converted the sequence count equal to minus 1 all time. Okay, the sequence count equal to minus 1 done. So when we having 1 0 mean perform by subtraction operation one time. But we will not do from a subtraction operation, instead apply by subtraction operation, minus some value converted into the 2's complement be there, perform from the addition operation will take place. Similarly, go from as a 0 1 mean after perform by the arithmetic have a subtraction operation, go from arithmetic subtract and sequence count equal to minus 1. Similarly, go from as a 0 1 and go from as a 0 1 is there, we perform as the accumulator value plus adding from as the multiplicand value. We want to add after perform by the arithmetic separate operation, sequence count want to be decrement by 1. When the sequence count equal to 0, you want to stop the process. Sequence count not equal to 0, the process be repeating. Okay, this from as the our flow chart. Both the algorithm is a flow chart. Okay, now you go to this the process. Okay, what a number we having? We having the number will be converted as a, this is our number. Okay, what is the number is there? Just if you want to take from here, go table. This is already some examples solved from as the 4 comma 5. Now what you do? We have to change from as a minus 5 comma 5. So minus 5 comma 5 you want to apply by here 5, the number be added, so 5 become as a 0 1 or 1. So that number we can able to give them as a 0 in front I by inverted comma 0 1 or 1. Now a form from as a, this from as a ones complement want to done now this number, so having this a 1 0 1 0. Okay, after adding with 1, okay, adding with adding this one. Okay, we go from adding. Once we want to add now that number. Okay, we want to write this number. Okay, here if you want to add the number 1011, okay, it's become as a minus 5 value. Minus 5 value. Okay, so when having this minus 5 value, what is the answer is there? That value we can able to write here. The value equal to 1011. This particular value comes from as a first. This become as a multiplicand value. Multiplicand value. Okay, this become as a multiplier value. Multiplier value that means as a here as a BR. This become as a QR. Okay, having this a 5, having this a minus 5 equivalent number is having this a 101 from as first one. The second one perform from as a 2's complement want to perform, not 2's complement. 2's complement what will happen? The value become as is a 101. So 101 having this a 2's complement. So we'll say that when having it is a add operation, we want to apply by the 1011. Subtraction operation perform from as 0 101, perform from as the addition operation. Okay, what is having QR values are available? QR value also 0. So having this is 0 101. So this from as the our three inputs are there. We already know that having this is a Qn value. Qn minus 1 value equal to 0. Okay, and also I sequence counter want to set how many bits are used here. We using number having this is a 5. We having number having that is range is available. We have that is a 0 to 7 is available, you want to use the 4-bit counter. When having this is the 8 to 15s are there, you apply by the 5-bit value want to be applied, binary value. Like over 16 to some 31s are there, go from a 6-bit number want to be applied. This is only the our agenda. So here what is the process? We have in the number minus 5 into minus 5. We already know that. What is our operation? This is the operation. So what is our operation we required now as per the flow chart? Okay, when having the one zeros are come, subtraction done, perform from as the arithmetic shift, right? And I go from as the zero ones are there. Having this the zero ones are there. Perform from as the add and perform the arithmetic shift, right? Zero zero and having that is the zero zero. Okay, then I will to be as the one ones are there. Perform from as the no operation. So we are written by here as the zero zero or slash one one, written by the no operation. This from as the three steps will be there. Three steps are there. Now, when I want to initializing the value, this is our new value. So, what is our is the multiplicand value? We'll say here the multiplicand value is that this is a multiplicand. So, we want to give some color value for understand. This is having one color. This is having just opposite color. Just opposite color. Look, it's not visible. It is the black color only. So, it's having two colors are available. So, here what you'll do there. First of all, initial process. When I go to initial process, they having the table is available. Okay, this one is the previous one example. We have to remove this all. We have to remove. Okay, this and all we remove this one. Okay, what is the process? Inside process we remove. Okay, yeah, keep when the arithmetic shift right only there. That we applied some formulas or the formula. We are re-looping. That is only keep it by here. Just I think and all removed. All the value become as 0. I'll set by here also 0. Okay, not doing. I want to start the first process. I mean, this is the initial process. I go from as the initialization. What is the accumulator? Accumulator setting from as 0, 0, 0, 0, 0. What is the QR value? The QR value equal to 0, 1, not 1. 0, 1, 0, 1. Okay. What is the QN minus 1 value? 0. Seconds counter set by the 4-bit numbers are there. So what is our operation by here? The Qn minus 1 bit having is a 1 0. So you are written by the Qn comma Qn minus 1 bit equal to 1 0. So perform the operation go from as a 1 0 now. 1 0 had to perform the operation equal to sub. Sub means operation want to perform. Subtraction operation means accumulator. Uh, Accumulator then goes to this accumulator equal to accumulator plus accumulator minus BR okay, minus 11 is the BR. Okay, but minus number what you calculated minus BR means minus 5 2 point. So for that accumulator value is 0. So already I said here what is the add numbers are they add. When I go from as add, you want to perform by the this operation want to first of all you want to perform. Subtraction or subtraction values are come that I have perform as and this value you want to perform. This is again two process will be there. But here what is the query is sub. Sub mean what you do here, you want to add by the 0, 1, then I have to be 0, then 1. This one is our simple process. After perform the simple process, we having the value 0, 1 not 1. The subtraction value you have to apply from as 0, 1 not 1 want to be apply, you want to add. After the add by the 0, 1 not 1 value, just take down from as the what is previous bit value 0, 1 and 0, 1, 0, 1. That is from as the previous value you can write. Okay, this value keep it here. Now perform from as the arithmetic shift right want to perform arithmetic shift right. Okay, what I do here, I want take this bit is goes to here, this bit will come here, this bit is come here, this bit will come here, this bit will come here, this bit come here, this bit come here, this bit goes here. What a left out bit is there now is having one bit will sort is. What is having the last bit value is available is having the same bit value keep it by here. Now we having the sequence count equal to one time one decrement. Now we want to check what is our process. I having this qn comma qn comma qn minus 1. So the value become that is 0 1. Qn comma qn minus 1 value equal to 0 1. 0 1. What is the process? 0 1 mean add. So you want to perform from as here as the add operation. Here having that is the AC plus BR. Okay, when I go from as add operation, you want to take this particular value. The value having is a 1 0 then 1 1. Okay, now perform from as the addition operation be carried out. So having this is 0 0 plus 1 equal to is a 1. The 1 plus 1 equal to 0, carry is the 1. So here having the 1 is there. So you want to take by the addition process be done. That is the result is there. Double 1, 1 not 1 is there. Double 1, 1 not 1. For a purpose only, I remove the table. If not, okay. Now we can see that 1101s are there. Just take it from as is the QR value 1, 0, then as a 1, comma 0. We take down. Okay, after take down the value, now perform from as a after perform as add operation, go from as a arithmetic shift right operation we perform. Arithmetic shift right want to perform here. The number here already set now. This value come here, this value come here, this value goes to here, this value come here, this value come here, this value come here. The one bit we left out now. The left out bit, what is the last bit values are available, we keep it by last bit value. The sequence counter equal to as it is the one more time means sequence counter equal to minus 1 time. So this is the one step process. Okay, we'll give them as the outer border. One step process. This become as the second step process. Okay, when I have a sequence counter equal to 0 will be received, you want to stop. Now not having the 0, simply we have to here we have to apply the formula. The formula is that is having this is a qn minus 1 bit having this is a 1 0. 1 0 mean you want to perform this operation called a from a subtraction operation carried out. What subtraction value? 0 1 0 1 1 0 1. You want to perform the subtraction operation. For the value is 0 not 1, perform the addition operation done. So having is a 1, then here 1, here 0, here also become 0. So you take down the value, what is the previous values are there? Okay, this value some empty 1 1 0 1. Okay, you want to take the value. Now this value converting by the arithmetic shift right 1 to 10. So this 0 will be referred by here. Suppose for you only I say the references this 0, this 0, this 1 and this 1, this 1 and this 1. This goes to here. Automatically we set from as the qn value as the setting with the side split done. Last bit value having zeros are there. Here zeros are there, so they have to return by 0. Sequence counter equal to minus 1. Having the third step will be completed. Third step will be as the complete step. Okay, fourth step what happened now? We got the value become as 0 1. 0 1 mean add. Add mean what value going to add? 1 0 double 1. So 1 0 double 1. So you want to add. When you want to add now, this value become as 0. Then this value becomes 0. Then this value become as a 1. This value become as a 1. So take down the previous value 1 1 1 0. So you want to from as arithmetic shift right want to perform here. This operation want to be repeated. So you want to keep here. So what is last value is 1. So we have taken this value from the previous answer. So both the answer is correct. So you can check here what is the answer we received. Triple 1 0 0 triple 1. So we got the value is triple 1 0. So triple 1 0. This value becomes as it is a minus 25. So our answer be received through this table. So we have to form from as a minus 5 into minus 5. The minus 5 into minus 5 equal to is a minus 25. 25 as a convert in the binary value. Decimal to binary. Okay, we want to keep this reference. So the number having it is like we consider as a 8 bit number only. Triple 1 0, then 0 triple 1. Okay, so triple 1 0 0 triple 1. So we got the answer correct. Thank you. First of all, I want to click by the calculate. We want to take by the binary value calculator. Binary calculator. What is having is the minus 6 and plus 6 value be calculated. First, I want to do that one. Once complete here now, multiplicand is 0 minus 6 for corresponding minus 6 corresponding value that is a 1010. Then having there is the same value converted into the 2's complement value. It is having there is 0110. So after that, having calculating all the value, the here having the speed is there. Speed you want adjusting the how we can able to come. For we are creating a flowchart also given flowchart. From the flowchart, you can able to start from the start accumulator and the qn minus 1 sequence counter and what is the multiplier, what is the multiplier and all we have to give. You want to check from as the q0 and the q1 there. We have 0 0 mean go from as arithmetic shift right operation by the all. After having sequence counter equal to sequence counter minus 1. Like from as the 1 zeros are there, you perform from as a AC equal to AC minus m. That is a subtraction want to perform. Now 0 1 is there, AC equal to AC plus m want to perform. Auto performed by each and every operation. Sequence counter want to check. Sequence counter equal to 0 now. You have to stop it. Okay, if we not 0 now, go for that. While giving the here number of bit want to be assigned, that is nothing that we having the number is there. 0 to 7s are there. The number I have to go from as the 4 bit numbers are used. Okay, because the why are using the 3 bits not required, but why are using the 4 bit now? We had sign bits I have to represented. That is only the 4 bits I have to represented. 0 to 7. After having there is a 8 to 15s are there, go from as a 5 bits are there, 5 bit have to apply. Suppose see from here, when I give from 8, calculator here, you see by 5 bits are there. When I apply by the above 16s I have to apply, go from 60 bit to 1 to introduce. That is from as a our calculation purpose. When I go from as a minus 5, okay, then I have to be as a 4 want to compute it. So we know the value is minus 5 into 4 having minus 20 is are there. So how we can able to process now? Calculate that one automatically minus 5 computed. This having that is minus this one as the is a 2's complement of the minus 5 calculated. Here having this that corresponding in this value minus 5 converted into 2's complement means 0 not 1 will be there. Now we want first process be there. Initialize process will be done. Initialize process. The assigning by the accumulator value 4 bit value is assigned, 4 bit is assigned. And having the q not equal to 0. Sequence count equal to 4b assigned. Next process you want to check the value. This q naught minus q naught n and q n q minus 1 become as 0 zeros are there. 0 0. You'll see here first check the condition is 0 0. Go from as there's a arithmetic shift right want to perform. Arithmetic shift right now once right shift want to perform here. Once run from right shift, this particular one you have to move from here. Then after sequence counter equal to 1 decremented. Now you want to check them as the q naught and q naught value. Next step having the 0 0. That is also confirmed with the same process be as repeated. Having the here 1 0, here 1 is come. Now you perform from that is the next one, next process one perform. Now the value equal to 1 0 1 0. Now come from here as a 1 0 1 0 perform from as the accumulator minus m. The minus m come from as the minus m already computed as a 1 0 1 1. We are computing that we have to get a minus 5 now, minus and minus plus, so we have to return with 2's complement of that is a m want to calculate it. So 0 not 1 there, 0 not 1 we want to add here. After add here, perform from as one more time to here, arithmetic shift right want to perform. Arithmetic shift right want to perform. The after perform arithmetic shift right, counter value want to give into 1. Arithmetic shift right want to perform. 1 not 1 is there, the 1 not 1 come here, 1 will be goes there. When last bit, what bit is there now? That will be come from as a here. Missing bit value also come here. Next value come from as 0 1s are perform from as a plus m. A plus m means this is 1 1 1 1 1 0 1 want to be added. A plus n. This is from as after performing by the this value and having this 1011 want to add it, that is become as that is the values are there. So we want to, after adding the result having 1101s are there. Now perform from as arithmetic shift right want to perform. Here having the 10110 will become here. What are left out bit is there? What is sign bit is it become here? Here 1 will become here. Already 1 is there. 0 will be 0 go there. 1 go here. This is the result for that. What is having this minus 20 value is there, 110 1100. So having 1110 1100, so we can get that as the answer for that. Thank you.